Hmm. Hang up. Mute. So you choose to have voice on or not? Or do I just have to... Oh, it did start that up. Alright, so that's the boosted mic for the room. Actually, I need to... Yeah. We need window capture. Oh wait, window capture doesn't work. Display capture. Oh. You go away. And then we chop that down to just the chat. Good. So something like that. Alright, so actually if I need to have audio on, then do I even need the call? I don't know. Alright, audio on. Let's get that off. Let's get... Oh, you're here. Underneath all my windows. Alright, that check. Alright, cool. Well, I've got way too much stuff in the way, but there we go. Alright. Alright, so this is an adventure. So I'm trying out Watch Me Work, which... Really? Oh my gosh, I turn off the bleeping... Alright. Privyet, Alex Wolf. I need you off for a bit. System preferences. Where's the screensaver? Never. We'll do that for now. Alright, so this is a lovely little mess where I try to get on Watch Me Work, which is people doing, normally we're doing programming. Today I'm doing presentation stuff. That means being on YouTube, so we got Restream, and apparently Watch Me Work has their own chat on top of that, which might just be in-group chat. Remains to be seen. Alright, so what I'm doing, and I may have to drop some of these windows because it's going to get really crowded here, is I need to outline this thing, and the way I usually do that is to get a bunch of sticky notes on a wall and rearrange them and scramble things up and work it out that way, or it's a very tactile, hands-on method of sort of seeing everything out. And the way I've got this laid out here, and I've got too much stuff in the way, is the 30-minute presentation. I've got 1 slot per minute, and I usually do around 4 slides per minute, and those will kind of condense the ideas that I've got going on. You know, it sort of serve as my outline for how I'm going to organize everything. So, let's see. I usually start off. I do use color markers sometimes. I'm not sure. I mean, I had to play with the gain and exposure settings on the camera to even get the text on these to show up a little bit. I do not exactly have studio lighting here, so that's an unfortunate thing. So the rough title we're going with is Next Generation Authentication. So, and sometimes I'll play with the order a little bit to put in a hook or something before I get into the title. But we're going to have a title somewhere. So it's going to be Next Generation Authentication. And I don't need to have that super, you might be able to read that, super detailed there. And then somewhere we're going to have, did I end up doing this in another color just as the background? Somewhere we're going to have, you know, a little, hi, I'm Wondable, I do cool stuff, that's who I am, where to find me. At some point we're going to have some kind of outline. And I don't entirely have that structure yet. Right now we're looking at one based on the kind of threats we're dealing with. And that will hopefully kind of cover the first minute or so. Now, what I think I've done before is I actually put a little hook before the title. It's like problem statement. You know, security is terrible, passwords are terrible. Okay. Oh, and today what, Alex? I just see what's going on. Okay, today. I need a little more context. Alright, so the structure I've got so far is based on threat models. Or what are the problems, the specific problems with the current, especially password. And we'll probably have to touch on, have to figure out if I want to touch on two-factor and how that is maybe an issue or maybe not. So actually, these are going to be kind of headings. Maybe I should have done master heading and something different. So the things I might touch on, and we'll see how this all spaces out, but we'll just kind of have them for now, is one of the big issues with passwords is that if the password database gets out, then all of those accounts are compromised on that machine. Well, potentially. It might be worth touching on what the general good practices for password databases in general. So we have theft of the server database, which is a mess. Let me know what we're talking about. We know at some point we want to talk about That's yeah. This is the part of the thing I'm trying to figure out. A point I want to touch on at some point, particularly because it's relevant to SQRL, is the privacy and cross-site tracking. Yeah, maybe more tracking. And right now, that's kind of lined up as our second point. And I did have, and I've got a bunch of other points I need to break out here. These are going to be like the big titles. So, weak authentication. Weak. And I might have to break that out as actually 2 points at some point. Actually, those are... It's probably going to spread out more than that. Just because of the amount of things I have under those. So the other thing we had was... so that's weak authentication. You know, loss of user information, e.g. they just forget. You could phrase that as user DB for comparison to server DB. So we have loss of user info, and how do you do account resets? You just want to lose something. We're probably going to be getting at least this far in by this point. We have theft of user info. Okay, now it's not just you've lost it and need to reset it. It is somebody else has all of your information, and what can they do with it? And I'll end up somewhere down there. And I don't know... I can set up the top level points here and we'll see if we get to them. We have network attacks. Man in the middle. And these I might just kind of hang out here at the end for now and develop them if it looks like we'll have time. We have untrusted computers. And see, and I also had I don't know, hard to use, user error, and second factor attacks is like stealing a phone SIM that is used for SMS codes. That's almost more social engineering, but so we've got, this is a tenuous point. It more goes to SQRL is being kind of clicking in, and then we have possibly second factor, e.g. SIM stealing. And I don't know if I'll get to those. So for the points I do have, we're looking at theft of the server database as a way to introduce where was I putting agents? Oh, I've got that under the weak authentication right now. So that's one of the things I need to sort out what order I'm putting those. So server database, and I might almost want another color for this, because these are like our big These are more, this is like a solution. What about green? Maybe I should have done threats in red. That'd be more of a stylistic thing for the actual presentation. So one of the big points we're going to talk about is public key cryptography. And right now we're putting that under here. Other big points for privacy, it's just being unique. It's more of a SQRL thing. For authentication, a big theme, well, I've got the green out, is agents. And I have no idea where this is going to go out time-wise right now. Alright. Basic black. Alright, so we've got a thing that's been showing up in the things I've looked at, which doesn't necessarily mean anything, but it's this thing that I've looked at. A particular form of public key cryptography known as elliptic curves. I might actually have to do some conceptual breakdown of that, which will put that into at least the next point. And then under that, we've got 256 is the new black. We've got efficiency arguments. Particular to at least the one SQRL's using is arbitrary private keys. I don't have a good way to state that. But it's the aspect of SQRL, and one of the interesting things. So I don't know if that's super useful, but it is interesting because it means you're not. It means it can be derived. And we might. There's a lot of things that are using libsodium or NaCl. That's probably more than a minute's worth of stuff right there. All right, privacy and tracking. Is unique keys a major solution? I mean, public keys are a big thing. Agents are a big thing. All right, there's not a whole lot going on here. Oh, and that's like super high priority. Get that out of the way. So we'll keep these black for now. So we have for site keys. This is a little bit too specific to SQRL, but it's more details about how it does it. We have, how do you state that? Sites can still ask for whatever they want. Personal information optional, I guess. Personal info optional. At which point, theft of database with the same user. So things could still be somewhat correlated. Oh no, that was actually an attack. Didn't quite qualify as a major point. Theft of related database. All right, so we have all right, weak authentication. We want basic black. All right, we got agents. We return to public keys. It's in that same, there's also a solution to that. All right, so yeah, we still have how do you secure the private key? Which can be a whole topic in and of itself. All right, so loss of user info, multi-level keys is another thing that I want to touch on because that showed up a couple of times. And that kind of ends up covering some of the theft stuff. So maybe we'll see if we can, if that works out to half an hour, and then we can add on stuff we need to. Or I could elaborate it all out as slides for in case there's questions and stuff. All right, so multi-level keys. We're doing blue, right? No, we were doing green. That was under loss of user info. And that ends up being very similar to theft. And offline storage. That kind of goes along with the multi-level keys. I don't know if that would be a major thing. And then, let's see, how far do I want to take the rest of these? Well, I still owned a lot of ground to cover. I know one thing I was thinking I can elaborate on is when we get to agents, we've got a couple different types of agents we can talk about. And I'll have to see how this orders. Well, it will almost certainly be a little bit lower if we're talking about that stuff. Because examples of agents are password managers, we've got cryptocurrency wallets. In our of interest to us, maybe specifically Ethereum. We'll just say cryptocurrency wallet. And specifically with MetaMask signing stuff. Where are you sort of have that with specific application-specific apps. Yeah, so Google has a thing. Sometimes they'll send a code or ask you to authenticate on another device. And of course, SQRL. So that's under agents. Where do we insert public keys into that? Do we do password managers? At this point, we've already covered theft of the server database, so we could probably say that we've got that. Or how about we do password managers under agents? And of course, I'm going to be right in the middle of what I'm working on with the camera angles. Then we go into public keys. Apps may or may not be public keys, I don't know. We know that cryptocurrency wallets and SQRL are based on public keys. I've also seen SSH agents, which are also based on public keys. Just RSA or DSA ones, I think. No, that is it's kind of last generation, but it's still an example of that working. And then an agent has to secure the private key. That is going to be a critical feature. And I was looking at that going well into loss of user info. All right, we've already got that much outlined out. All right, so those are going to be optional points. Might want to get into theft of user info. So that gets into SQRL is a really neat thing where it does multiple levels of passwords. So you've got your at-rest password, and then you can use a shorter one. Every time you go back to the app, so that a random person can't walk up because they still need to know that short password. And if that's wrong once, then you're back to the full thing. So that's a point we want to get in there somewhere. Somewhere we've got multi-level keys and offline storage. That's sort of a bridging topic. Okay, I had encryption under theft. Yeah, okay, I botched that. Man, why do I keep wanting to do a K on that? Okay, so we want to make sure we're encrypting stuff. We have multiple levels of encryption and passwords. I think is kind of neat from a user experience perspective because you still have to secure it somehow. And then theft is under multi-level keys as well, because that gives you your offline key you can restore from. So I had a bunch of stuff under Men in the Middle about domain-based keys, nonces, IP checking. Nonces aren't next generation necessarily. Oh, let's... Oh, join the chat, not join the... Okay. All right, so I need to, so these are kind of my big points. So I need to see how much time is this going to reasonably take up. All right, so we're going to have, I'm going to end up covering a lot of the threats down here. Maybe I could actually do the outline first and say, okay, these are the threats we've got. Now we're going to talk about next generation auth. Little bump to me. So first threat is loss of the server database. And if we've got, we could touch on current gen, which is hashing things, which avoids, I think I put associated databases somewhere. Anyway. Well, I guess only badly hashed databases are a real threat. But it still allows them to do offline password decryption attacks. So I guess the most newsworthy thing is we get databases stolen all the time. That leads on to a lot of things like possibly encrypting the databases so that you're not leaking the personal information and such, but from the pure authentication perspective, we want to make sure that we're not leaking any authentication information when that happens. Which leads us to public-private key cryptography. And this is where I know I'm covering some of these points in the existing presentation. Yeah, so I started off with, so there's an app. Yeah, so this is where we're kind of doing some of the threats and weird password stuff. So it's actually starting up a little bit the same, with a little bit more elaboration. Alright, public-private key cryptography. Yeah, so I think left in the middle look too high level. So yeah, example is, yeah, they might want to touch on SSH again. Because that is an example of public-private key cryptography as a concept. And then we go into the current use of elliptic curve cryptography. Okay, user experience. That's another, okay, nothing to lose. That's more SQRL specific stuff. Okay, so I've got a little bit where we do, that's specific, that's public-private key, but it's specific to how SQRL does it. Yes, this is like super high level. Do I have any of my stuff in my older... Okay, we can use that to touch on what is elliptic curve cryptography. And we've got... Did I touch on libsodium here? Yeah, a little bit. So, super high level, what is it? How does it work? So, we've already got elliptic curve. This is more of a SQRL specific thing that might get cut. So we'll say elliptic, well, I've got that in the thing. So I've currently got that in my elliptic curve slide. But maybe I want to put off getting into how it works until we say everybody's using it. I could probably talk about efficiency as we get into or as part of that. Part of that is key size. And actually have to look up references on exactly how the efficiency and such compares. You could set this up as, well, you may have noticed that all these things have 256-bit keys. That's related to, which is itself a benefit. That's related to elliptic curves, which we've got. So this is, we've got that. And oh, by the way, it's that one. And then we've got a very brief idea of how that works. We can reinforce that with efficiency. Okay, mic's definitely on. And that might get cut. Or I could talk about it in context with this. So one of our big threats is theft of the server database. And that effectively comes down to, and Doug and Mike, thank you for the host. So theft of the server database. I didn't really touch on shared secrets as being the problem there. Oh, and did this default to audio off? It did.
Now I've actually got a bit more, just so that do this character here.
Yeah, so that's the interesting thing, is that like everyone's trying to do their little monologue here. Okay. Yeah, that's... It's like the whole point is to be working together. Oh wait, there was chat. Oh man. David Jeff. Yeah, looks like I missed somebody. Oh well. Well, points be working. Alright, so we need to touch on shared secrets. Setting up why we want public keys, because shared secrets can be lost. Encryption is important. Too much stuff. Solution to that is public keys, as you may have seen them in SSH. Lots of people are doing that because you may have seen 256-bit keys a lot. Those in particular are related to elliptic curves. They work by mathematical functions. There is a family of mathematical functions. In particular, I think SQRL is using this one. It's implemented in libsodium. I almost have to talk about that with key size, which is going to start pushing that down into multiple minutes. We'll have to get that in rehearsal, maybe. Well, okay, so it's not going on right now. Of course, my head's in the way half the time. Alright. So that looks like it's going to start pushing off that point. So you're going to go down at least one. We've got elliptic curves. we're starting to introduce that. Maybe that means we'll have time to talk about this. Maybe. That'll come down to a little bit of rehearsal. But I tend to run around 4 points per minute, so that's kind of a guideline for how long it's going to take. So that'll be like the first 5 minutes. Alright, so public key. So then we get... Well, no, it's only the first 4 minutes right now, actually. Might need... I might actually need to expand that. We'll have to see how it speaks out. And I also had some other stuff in my previous slides that elaborates on the problems with some of these things. So that could also take up a little bit of time, but I think that was a little bit too high-level presentation. So this touches on high-level, elliptic curve, how it works, concept of public keys. And it's currently awkward in my flow, but we've got I guess tracking is more of like one of the big trends. And this is not necessarily in everything, but it goes along with, it kind of flows through public keys.
Life, I guess. I got some.
Yeah, privacy is a bit more of a SQRL-specific thing that might have to get booted to an extra topic. Actually, that could go along with a form of... That's sort of an indirect form of theft. So then we're going to get into, and I'm still struggling with the order of public keys versus agents as a topic presentation order. Agents flows better into the whole loss and theft of user info. And I guess we could actually break this down as like server problems and client problems, or user problems. Alright, so probably the outline is a little bit more useful here. Oh, okay, that was the wrong... There we go. Alright, so another problem is we've got... Yeah, so we could direct this down as, let's see... Server problems and user problems. Or server attacks and user attacks. Man in the middle, somewhere in the middle. Which it is. Ease of use is not an attack, it's a problem. Second factor is a problem for both. So right now I've got theft of server database and theft of related databases attacking the user. On the user side, we've got bad passwords, we've got loss of user info, we've got theft of user info, and being tracked. I'm almost thinking theft of related database might actually be like the more important reason that we have user specific IDs, but I might actually have to introduce other concepts before that makes sense. How do I on time? Okay, cool. So we're considering threats. Did I show you? Well, the weak passwords leads us into the topic of agents, which is a big theme. So then we get into the password weakness arguments, and also that gets into a little bit of user ease of use arguments. So I know we've got some existing material for that kind of ended up here. Yeah, password resets. And reuse forgotten.
Hello, you left my woodland art or eagle.
So things I've got available are, well, we've got weak passwords, we've got schemes, we've got reuse. Wrong one, but it worked.
Yeah.
All right. Where am I at? So we've got, we already kind of got weak there. We've also got, we've got all the passwords. We could maybe touch on password schemes, and that will become this entire point. Hold that space here. I'm not using it right now. We move down to agents as the solution. Alright, so we've got password schemes, we've got, well,
Right, Mom. True or false?
actually forgotten goes down to loss of user info, doesn't it? Well, we could still touch on it. Because that's still a threat on the agent model because you've got local files. I might need to expand on that. We might want to bring over some other stuff on the server side. Probably need to touch on second factor somewhere, not sure where. Alright, so we also have weaknesses in the passwords themselves. People tend to use bad passwords. Oh, actually, I have reuse. That was the other one. My black marker's dying here. People tend to choose bad passwords. That leads to all sorts of password schemes, which makes them impossible, which makes them difficult to actually remember. So you have to worry about remembering the passwords. The harder they are, the more tempting it is to reuse them. One of the currently best solutions is to use a password manager, actually. That introduces the concept of an agent. And in many cases, we also have application-specific applications. There's beautiful language. Application-specific services. I know, for instance, Google has a thing where they'll send like a ping to the Google app saying, do you authorize this? Some specific applications will send a code to the application that you put into the website. Or, of course, there's the SMS, which has its own issues with things being stolen, second factor attacks. This brings us back to public keys, which we already discussed above. I've got SSH twice, but I've used, I know in PuTTY, you had the option to have an agent which would unlock a password-protected SSH key for you, so you didn't have to put in the password every time. So that was sort of keeping a cache in memory, so to speak. You can also see this today with cryptocurrency wallets, which will unlock the wallet and unencrypt the private key so that you can make signatures and transactions conveniently. And we've also seen MetaMask, the ability to make signatures, such as signing up for CryptoKitties, using that information. And then we've got SQRL, which is it's essentially the same thing. You've got an agent that has a private key. We'll get into multi-level keys later. That it uses to sign into sites, and it has some additional levels of indirection there, which would get into the privacy tracking and multi-site keys. But essentially, there is a root identity key that you care about. I think it's identity master key. How much do we want to talk about SQRL's management? Well, securing the private key might get more into secures. Multi-level encryption, multi-level keys, offline storage.
Maybe even use the scaling tools.
It's offline storage.
Mess around with the actual
Multi-level encryption is getting into that. Maybe securing the private key actually comes down to the next 2 points. You can do it at a high level there, and then break it down into our other threat models of the user information. Alright, so this is where I probably have to start sketching this out. Well, I need to check it for flow, and then I have to check it for time. And see how much we want to get into the client-side. The client-side encryption is, we can talk about that. And I've got a baseline for agents. I have done nothing to elaborate multi-level keys. It's kind of a new concept. So one level is offline storage. What else are we going to have here? We're going to have so let's just say we're going to have a subheading for SQRL, and maybe I can. I also looked at some stuff with, I know, well, we know we've got the Ethereum wallet said, here's these words, these are your private key. Also did a little bit of research on Spider Oak Semaphore. Which had the recovery keys. It also, let's just touch on theft as well. So yeah, loss touches on multi-level. You have to have something you can go back to. You know, if you just, your hard drive died or whatever. That's kind of offline storage. That is MetaMask recovery code, put it someplace else. Semaphore also says it goes to a set of words. SQRL does to a set of characters. And then those are things that can be used to reconstitute the private information. Alright, so MetaMask, set of words. Semaphore is a set of words, and what's my notes on that? Semaphore, multi-level key, pointing at keyring chains. We've got the recovery key, which is a set of words. Do I need to touch on key derivation kind of the same stuff. So, in addition to offline, we've got the concept of your, well, offline storage can be the private key. That protects you against the loss of the user info. Theft is where you really need to get into multi-level keys. So that's going to kind of blend over into the encryption part of it. So exactly where we present that is going to become a little bit ambiguous. So I know, so SQRL has the recovery code. It has, that goes down to the identity master key, which is heavily encrypted and everything. So loss of user information is offline recovery code. So this might kind of break things out into two parts. Semaphore so key derivation on the phrase HMAC to get public keys and encryption keys, some of which are regular use secret stored on the server, a recovery derived secret. Most keys stored in keyring, support rotation with, oh, yep, and rotation of keys. That's a rotation replacement of keys. That is particularly important to the theft side of the argument. So in Semaphore, that is key rings, and in SQRL we've got the recovery code gets you your I forgot what they call it. It's the unlock key? Identity unlock key, I think. Maybe I got that wrong. You've got the recovery code, you've got the identity unlock key. I'm going to have to double check that. And you've got the provision in the protocol for the, then you've got the identity master key and the sort of, is it previous identity master key? And then provisions in the protocol to rotate those. I'm wondering if I should also break out points for the attacks in the opening outline. Alright, so I've done a whole bunch of, oh, I've gotten into this stuff. And then this is maybe getting bumped out to this land, if ever. Because this is actually part of you. I need to start developing these as blocks. So, and then a little bit on the first section, a little bit in the second section. So when we start talking about loss of user information, so we could open up from the previous point, securing the private key. Maybe that becomes our transition. So one of the things we have to consider is loss of user information. We always have, the forgotten passwords. In the agent world, we have to consider hard drive died, file accidentally deleted, sold the computer and forgot about it, whatever. There's obviously there's backups. In particular, with these systems, what we often see is a trend toward offline storage. Or at least another computer, some sort of super light, I suppose, would be to reuse your password vault. So people may have been playing around with MetaMask from the last meeting. They gave them a bunch of words. That can be something you can write down, copy, print. Put in the password vault. That becomes an offline recoverable thing. Semaphore has a similar concern where your root identity is that same kind of private key derived from this random phrase. What we see in SQRL is they decide to do words. It could probably be done as words. They actually give you a encoding of the key. I'm gonna have to look up exactly if it's hex, if it's, I think there's like a 56-bit somewhere. That's some specs about how that I have to look up. So that gives you a recovery code, which is essentially, I'm going to have to look up whether it is the identity or if it is the encryption or decryption key for the identity. From that root identity, you get the identity master key, which is more of your daily driver, and that's actually that's something that Semaphore does as well. You have a main key which is used to define a daily driver. I'm not sure what to call that. Square calls the identity master key. I'll have to look up the Semaphore name. Account recovery key, KDF, HTTP, public keys, and encryption keys. Regular use secret. I'm going to go back to their docs to see if there's a name for that thing. A sort of daily use key. The concept we introduced there that corresponds to the identity master key in SQRL. So we're already touching on multiple levels of keys with these two, which is going to be kind of maybe our bridging concept out of MetaMask, which is the wallet is the key. There's no levels there. So we introduce that concept. And then look at how it develops. So I think I actually need to take a break about now. So I will be back in a minute or two. Da, 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 da. Okay. So, what do we got? We were first pass through lots of user info. And I'm kind of expecting this stuff to expand out as I rehearse and work out the details. Alright, so we introduced multi-level keys as things these are doing. Right now, it's only loss of user info. It's a way to get there. The big reason we use multi-level keys is because of, we're talking about theft of user information. Now, your first level of defense is just always encrypt everything at rest. Yeah, I'm going to have to circle back to multi-level keys. Or maybe go back, I start with theft and go back to user info. Actually, rotation follows on multi-level. I might want to bump this down so that I can kind of bridge over this with multi-level keys. Well, I almost have to introduce the concept there and then continue it here. So we can talk about rotation of keys. And I was like, well, you still don't want to, even though the keys can be replaced, you don't want to make that an eased thing you have to do very often. Yeah, so that starts to bridge into this. So then you have to consider not just the loss of these keys, but the theft of the keys, which is really the big reason that you've got multi-level keys. Not only is that other key something you can... Oh, hello. We actually have people in, let's see, where can we put this? It's blocking up the numbers a little bit. Actually, I'm not really doing this side yet. It'll kind of fit up there. So we've only got this. Another shot I have to keep an eye on. Alright, so we said we use multiple level keys here. We're putting that primarily as a way to get recovery of user information, but this also gives me excellent protection against theft of user information. Because having multiple levels of keys means that you've got the offline one that is completely secure. Well, hopefully secure. I mean, if you print it out and they steal your files, you know, gotta have security at every level. But the idea is that you can take that master key, you put it in your safe deposit box. It should not be easily stolen, so that if you do, I've completely neglected to focus on user responsibility. That is the big liability of the public-private key systems, which is where this all comes into play. Oh, and we have a new screen, which means we're going to have a new thing to unmute. Looks like some game development, probably. Alright, so this is something we're probably going to have to touch multiple times. So this has to be touched with public keys. This is our big liability. And this is also where we want to touch on this as, yeah. All right. That's going to be an awkward one. I might need to move that down to agents, because we kind of get into securing the private key. Actually, that blends into loss of user information. Get offline storage so that we've got a place to put it. Alright, so we've got rotation of keys. And right now so if it's stolen,
Put in there.
not only do we've got an offline backup. Now if it's just a backup as in MetaMask, then your Ethereum's gone. Although I guess in the cryptocurrency case, once they've stolen your information, it's gone. It's another language? Might be. Not going to be too useful to me. Alright, so rotation of keys. So it's in the cryptocurrency case, that's actually a little bit of a setup for, well, authentication is just different. And we could also set up some of the things that SQRL has, which is the locking protocol. And differentiation of rights between what a daily key can use versus a ultimate unlock key. The semaphore has key rings. Key rings have provisions to be cycled and replaced. They do have references to the previous ones, so I'm not sure if they can be disavowed, so to speak, in the case of loss. It might just be a case of rotating them regularly and using the most current ones. So yeah, in the cryptocurrency case, your currency may be gone. Your only defense is to try and transfer it before the bad guys do if you find out that your keys have been exfiltrated. Semaphore has this idea of multiple low-level keys. The master key defines the lower level key. And actually I have to double check if those are directly related and merely derived, or if you just create it and then encrypt it. Let's see, are public-private keys replaceable? My poor marker's dying here. Where is it? Alright. So that's a question I have to answer. It's a little bit of a distraction from my current focus. So if user information is theft, we've got rotation of keys. I guess we just have to say that wallets are gone. There do not currently have a built-in rotation protocol. Your only option is to make a new wallet and try to transfer your currency before they get you. For the authentication case, you have the possibility to rotate, but that would depend on differentiation of rights, because if they steal your account, they can, people have often we'll get into one account and they'll change the password, and now you're locked out. So, well, this concept of we've got multi-level keys. We've got levels and rights going into that, which is kind of why this is useful. And I have to get back to Semaphore to see if they have any, if their recovery keys have any aspect of that. All right, let's just put this up while we're using it. Get a little bit of stuff out of the way. Yeah, something else. Oh, okay. Alright, so in the case of theft, simply having offline storage is not enough. That can get your account back, but if it's cryptocurrency, unless you're really fast, your currency's already gone. Which is why it's useful to have, which is why the levels of accounts are especially useful, because you can define rights with the different levels of accounts, including the right of the higher level, more important key to rotate the lower level keys. And we have to look at, so Semaphore has a recovery key, but I have to see if that allows you to control replacement of your daily driver identity. SQRL defines its sort of master offline key as identity unlock key, I believe. I have to double check that as well. Which gets you your identity master key. The identity master key is, you don't want to rotate it. You shouldn't have to rotate it as long as you've secured your password vault and no issues. But if it did get out, you have the identity of the previous identity master key, which will actually show up in the protocol as a previous identity key because of the privacy stuff we haven't touched on yet. And we have the multiple levels of rights. Maybe I move that down, because I don't know if Semaphore does that. This is going to be at a local user group, just a general computing user group, so we touch on a lot of topics. Last time the meeting there was supposed to be something about Ethereum and authentication, and that person wasn't able to make it. We had another presentation about Ethereum in general. And I noticed one of the things that they did is they had, like, you could sign, like, they signed up for CryptoKitties by basically having an Ethereum address. And it's like, well, sign this thing, it's just CryptoKitties is the text. So I saw a lot of correspondence to a protocol I've kind of been watching called SQRL, which also uses public-private key, elliptic curve, crypto to do its signatures. So I am trying to do something that's kind of about SQRL, but also kind of about these similar things in Ethereum and other areas. I'm just looking at this other thing over. Alright, so right now this isn't related to me. If I have to get into something, I put that back. Yeah, yeah, I don't know. Oh, JavaScript web tokens, yeah. You know, I've actually not gotten too much into those. SQRL is a little bit of a bespoke thing. It sort of happens behind the scenes. You might be able to use JWT as a sort of, what's the right level? Right word. Transport layer for the signatures. But right now they've been focusing on trying to make it applicable to as many platforms as possible. And there was some issue with, like, PHP in a shared server environment not having access to the post parameters or to the post body. So they focused more on a like a standard MIME form parameter transport. But yeah, I mean, in theory, you could have multiple transport formats defined for it. You know, in like a version 2 or as like a MIME type for it. But right now, I'm focusing more on the sort of the public key and the trend towards agents and multiple levels of keys, so that you have defense against those kinds of attacks. You know, JWT versus MIME or web HTTP forms. That's the transport layer. It's protocol. It's not particularly anything next generation about it. It's, you know, it's a neat thing. It's part of the protocol, but it's not like the kind of topic that had come up within the group. But yeah, from what I've seen of JavaScript web tokens, and I don't know what's in or not in the standard, you have a thing that contains information and can be signed. So if they had elliptic curve crypto, that would work. But I mean, any public-private key system can be used to do that, of course. To do those signatures, it's just that and one of the things I need to get more research on is the efficiency stats of elliptic curve. You get 256 bits keys, relatively compact signatures. I'm pretty sure they were saying it's relatively efficient to compute. So it would be a nice way to sign JWTs. I'm pretty sure at one point I was trying to use the Twitch tokens from their authentication process. And it's like I was like having to pull in multiple libraries or libraries with dependencies and stuff to try and verify a JWT. Eventually I figured out that like the plain text you could just decode, so as long as you trusted that. Authenticating is to trust the token. which is what you're getting the signatures and stuff. But like for me, I was just like trying to ask, well, what's my user ID? And it turns out that was actually easier to get by if you do the users call without parameters, you figure out what your ID is. I didn't actually need to go through all the OAuth JWT stuff. Anyway, right now I'm trying to work out my theft of user information section of the presentation, and I'm going to keep looping on this. You know, right now I'm not really even up to 20 minutes. I know I'm going to have to elaborate on stuff, and I have things that this in no way represents the actual time of it now. You know, I sort of set this up so I can do that later, but right now I'm just kind of going on my rough... Yeah, I tend to do 4 slides a minute, which is kind of about 4 ideas per minute. So right now we're working on theft of user information. If we're looking at an Ethereum wallet, by the time you notice it's stolen, your currency is probably gone, but if you can beat them, you can transfer it to a different key. So what we would like to see is that we have multiple levels of accounts. The offline portion, for instance, being the higher level that is hopefully not stolen. And that will, let's see, did we touch on, okay, yeah, multiple levels of accounts. We touched on multiple level keys. And that has multiple levels of permission, one of those permissions being this less frequently used, more highly secured key can replace the lower level keys. So that if your daily driver key gets stolen, then your higher level key, which is not stolen and is still secure, can be used to rotate the lower level key, removing the attacker's access to the old stolen daily driver key. I need to go back and look at what Semaphore does. They've got a recovery key, which can certainly cover the I lost my information case. But I don't know about if you stole your information. Is there a provision to replace the identity because that identity is now forfeit? SQRL definitely has an identity unlock key whose purpose is to, it has a method to create new generations of identity master key. Then in the protocol there is a provision that says, well, here's my current identity and here's my previous identity. If you only know about my previous identity, upgrade to my new identity. And that requires a, well, I have to refresh myself in the protocol. If you have supplied certain additional pieces of information to be able to prove that assertion, to prove the lock assertion, you can set it up so that you have to have loaded your master key, which is, you know, dangerous for as far as being stolen again. But that allows you to make assertions that you are updating keys and it is safe to do so. You're not an attacker trying to replace your identity. So I'm actually have to talk about locking first. Well, there's lock and there's disable. So points. And we have to figure out how we do this. So that goes down to here. You have a provision to lock that, which does that, and then also, any key can disable the account. So if you're in a period where you discovered your identity master key was stolen, and you have not yet, you know, gone to your safe deposit box or whatever to get your unlock key or your rescue code, then you can go in and say, with only the rights of your daily driver key, your master key, you can disable the account. Now that means an attacker can lock you out of your accounts. Minor form of attack, you can come back and unlock it later, or enable it later. I have to figure out how to order that properly. So your identity unlock key derives the IAM key. Your master key can lock the account. which then allows you to submit the previous identity master key with the unlock to say it's okay to replace it, which the attacker cannot do. You know, they can do denial of service by disabling, but that's about it. So this is still really rough. And secondly, just of course, you want to, that might actually go under agents. That might work under agents. We'll have to see. And of course you want to be, even though you can replace things, oh. Okay. All right. Besides, another day. All right. Where's my head? And of course you want to be encrypting all this stuff at rest, so that if somebody just gets your files, you've still got, and you're back to passwords, but it's only one password. It's sort of at the same level as a password manager. And this is almost more of an agent thing. One of the things I found really, one of the nice things about the SQRL proposal that I don't know that and maybe I haven't paid enough attention, is the idea of multiple level of passwords to unlock it. So you've got your your long, hard to remember key that locks it at rest when it's on the disk. And then while you're using it, you just have like a shorter, like, I think one of the defaults is like the first 4 characters of your big long password, or the first n characters, but it's about 4. That locks it sort of at runtime, and then any failed attempts to enter that will just eject the important stuff from memory and require you to decrypt from your on-disk store with the master key again. No, we do have securing the private key. So that might kind of go down here. I mean, encryption is prevention against theft, but it's not especially next generation stuff. So now the question, so I think these are, we might get into tracking. We might get into tracking. We'll have to see, because right now I'm not filling it up, but there's a lot of detail I need to elaborate as well. So I need to look up Spider Oak and stuff and see how much I have there. I think this, oh no, I need that is there. All right, account recovery. That's a regular key. Do I still have that one up? Server to account. Where is account data structure? So how's my volume? I almost need to have both my mics on here. two different distances. So we've got recovery key, KDF, recovery key, salt, output to generate seed bytes used for account authentication's key pair. Level 1 secret key used in the event of it. Okay. Level 1 secret key, symmetric key used in the event of account compromise. The seed bytes are directly derived from the recovery key, though, and that is used to make the account authentication key pair. But we do have a level 2, level 2 secret key. 32 bytes of random used to encryption an account's communication key. Oh, encryption of an account's communication keyring. Stored in plain text, stored on the server, being encrypted by level 1. I don't know if they have a good... I mean, you've got organizations which can replace a user and just say, okay, you're a new person. The same rights. But this paper does not cover compromise in the detail I want. When end is discovered, end user device. But he reacted, all the devices are lost. End user device is going to be, the end user may recover by authenticating using higher level secret and rotating their key ring. All conversations automatically rotate keys. So they maintain user identity and use key ring rotation to essentially move all related stuff. So they retain identity, so someone still has... So if the account is compromised, they still have something to your identity. Account keyring. Encryption key pair, signing. Okay, so the identity is not used for signing or encryption. Okay. So their solution is not to change the identity, but to change the key ring that it contains the signing keys. So for semaphore, it is... My pro marker's dying. Which... Right, presumably only the recovery key information can initiate a keyring rotation. Otherwise, the attacker would just rotate the keyring for you. Alright, and we've gone silent again here. Alright, so that's a question Now I need to look up any stuff on SQRL again. I need to double check the name of that key. You know what? I just found a site. Let me go look that up real quick. Alright, so some people had started a SQRL spec project, have not yet looked at, oh boy, XML. Is this something we need to build? Yep, looks like it. No, I should need to do GU. I guess this would be a reference thing. Yep, Frankie. Oh, I gotta just change into it. XML to RFC. Oh, man. Oh, yep. All my stuff got reset on here. Oh, no formula found. Closed pull request. Legacy homebrew. Alright, well. XML RPC. I don't want RPC. XML editor. Alright, it's OSX is apparently confusing it. How do we exclude things? Fewer dogs and results. Oops. Oh. Okay. Oh, it's Python. I don't know if I've got a sufficient environment for that right now. Okay, we got something. Anything going on over here? Oh, we do have some other people maybe speaking English. Yeah, that could be written on the speaker. All right. Oh man, pulling all sorts of specs. All right. All right. Well, they've got some text in here already. Oh, interesting. Breakdown. Class A, Class B, Class C. Identity, okay, it is identity unlock key. Unlock request signing key. I don't remember exactly how that flows. Rescue code, obviously. Password derived keys. Alright, let's bump this up for a little bit. Okay, so I need to refresh myself on exactly how this stuff sticks together. Okay, previous identity. Yeah, that'll go the specifics of that. Public key, identity management, identity life cycle. Identity unlock. Master key from which all aspects of identity are derived. Public key of the identity unlock key. Yeah, that makes. I guess as long as it stays private. Private stays private. Okay, base 56. This is algorithmic. Standard algorithms. Hash and script. Maybe I should. Yeah, I don't really have anything there. Alright, private key. It's actually a private key. Unlike request sign key, okay, that makes sense. I forget if that's... Well, the rescue code is not the identity unlock key, so I think it might be an encryption for it. Rescue code derived key. This is all client storage stuff. Rescue identity. Yep, okay. The identity unlock key is stored, but it's encrypted with the rescue key. So you do want to make sure you have both. Oh, okay, so we still have a lot of to-do sections. Oh, yeah, enabling disable site login. Tag formats. Yeah, they've collected some good stuff here. Alright, so that kind of refreshed me on rescue codes versus identity unlock. Where does... So where does that put us? No, actually need to be over here. Get that down somewhere around there. So SQRL has a recovery code, but it is not the identity unlock key. So that's not a multi-level key. That is actually an encryption thing. That gets down. That's actually part of your multi-level encryption. And the identity unlock key is part of, well, loss of user info. Oh, yeah. It's multiple levels of encryption. The recovery code is something you write down. If it's encrypted, the unlock key with the recovery code, you still have to have a copy of that, or you can never recover it. I wonder if there's if they've got a section on recovery yet. All right, done with you. Entity recovery. Or I lost their identity file. And default options, rescue code. Validate the rescue code by decrypting lost identity file. Validate the rescue code by decrypting. Oh, you know what? I think the offline backup might actually be like a QR code of a storage format, because they're talking about decrypting a block. It's rekeying. Yeah, that doesn't clearly importing, exporting. Then decreation. Right, I encourage the user to back up the new identity in offline format. Okay, so there are basically storing the file and the rescue code in an offline format. So it's not just recovery code here. It is loss of user info. This is recovery code plus backup. Whereas semaphore has a recovery code that is the actual key. So it is, we've got you back up to words, semaphore backs up to words. Okay, from a loss of user info perspective, the semaphore system is about the same. You've got a backup, you've got your daily use stuff that you keep locally. I need to even though I don't need to elaborate efficiency on here, I need to be able to kind of figure out what I want to say about it. So we're back to there. I don't have any references on that yet, do I? Did I get anything in here? Elliptic curve, that's Bitcoin's curve. I don't have any specific references. Anything here? Oh, this is an old reference, but it could be a good one. Oh, updated. Wait. Oh, SSH has an option for it now. Okay. So this is a good reference. Sneaker chat. Group chat. Secure stateless tokens. Not listing SQRL there. Oh, hardware. SSH software. Okay, so when I was looking up SSH stuff, I only saw the RSA and DSA. So this would actually be a good thing to point out as a particular reference. Oh, okay, it is down here in software. Oh, yeah, I guess software works. It's not. It's sort of a protocol, it's sort of not. TSO, NACL. Wow. Oh, libraries. That's another good one. Cryptocurrencies. Okay, the others use elliptic curve, not necessarily this elliptic curve. Alright, so that isn't necessarily references to the efficiency argument. Oh, yeah. Okay, fast signature verification. Okay, I don't have a comparison to other very fast signing, fast key generation, collision resistance, small signatures, small keys. Maybe we need to go back to Wikipedia have more general information on that. Implementation. Rationale. Smaller key size, reducing storage. Primary benefit is smaller key size. Alright, so we've got breakage up to 112-bit, and we're mostly using 256. Alright, so people might be citing efficiency. Well, this one doesn't cite it. This says it is fast and very fast. Unfortunately, I have no grounds for what the... Oh, bench.crypto. Crypto benchmark. Couple of key signatures. Okay, I don't know what the red means. Measurements with large variance, indicated with red question marks. Ah, so interesting. Cycles to generate key pair, cycles to sign, which are probably more interesting to us. So some of these are definitely less. Where is... So that doesn't have large variance. Quartile, median... Unfortunately, I don't know. Where was our standard, like RSA, DSA? I guess I don't know the names of them. In this scheme. Yeah, so this doesn't give me really good comparison because I don't see like well, let's see, it's a big page. Oh, PQ RSA, which is a wee bit longer. Of course, we've got different scenarios here. So, yeah, these are, basically huge. Okay, well. Anyway, that was that. Alright. Yep, I actually scrolled that off. Alright, anyway, so our primary, that might just, we'll just say that it's still efficient. It does not, well, that page described it as fast. I might have to spend some time looking for better substantiation of that, though, with some more specific searches. But we want to focus mainly on small keys, I think, at this point. This is not as much progress as I was hoping for. So right now we're focusing on we're opening with, we've got a lot of problems with current authentication systems. There are frequent instances where user databases are stolen completely, along with their associated login information, which is, we cross our fingers and hope is properly hashed and salted and everything, and we often find that's not the case. the passwords themselves are weak and reused and poorly defined and sometimes forgotten. And they're sometimes forgotten. And if it's not subject to memory, then it's subject to loss of disks or even outright. Theft of user info. Do we have to touch on phishing? Network man in the middle, untrusted computer. Phishing sort of falls under network man in the middle. It might qualify as a separate thing. I'm going to put it off to the side for now. And we also have people having their databases stolen, their passwords. You know what? Without the per site keys, that might actually be a better argument for the per site keys than tracking. That's more of a side benefit at that point. Alright, so that's alright. I just had to switch sides for that, assuming it's even readable. Yeah, so phishing is more of a general concern and is a definite, well, it's more of a targeted attack than a widespread attack. But that might actually be the better argument for that. It's the pre-site keys that protect lookalike sites from getting a signature from the user that is of any use at the first site. And that's sort of a man-in-the-middle attack if they're trying to gather your information and use it. So we'll have to see how much we have time for. I might also develop some of it as like bonus content if there are questions or if time allows. Anywho, so most of it back over here, and I'm not really using that right now. So the outline that we lay out is we have problems with database theft, we have problems with passwords are just awful. They can be forgotten, they can be stolen. I don't have time to go into the rest. And I need to drink. So what we want to talk about is next generation authentication. Hi, I'm Wendable. I do cool stuff. I've been following this for a while. Here's where you can find me. One of the big concerns we have is that security is never perfect, and on a lot of sites and servers it is a lot less perfect than on others. Databases get stolen, they get exfiltrated. You have interns and insider things that can happen, and there are definitely steps you can take to do that. Properly hashed and salted passwords do not directly reveal passwords. Done properly, I don't think loss of the database directly gives you access to the system if everything is done right. But the fundamental problem here is that the information necessary to log into the system is in that database. There are a lot of secondary problems like loss of personal information that might also argument for encryption, and you pray they don't catch the database unencrypted. But having shared secrets just leaves us so much room for incorrect encryption, or incorrect hashing and salting, comparison of password databases and correlation across databases. So this, a next generation authentication system is not going to deal with shared secrets. It leaves so much room for somebody else to mess things up for you. And that does unfortunately create a little more user responsibility, which we'll have to touch on later. But the alternate that we're seeing in lots and lots of places, from SQRL, which is my main point of reference, to Bitcoin and Ethereum, is public key cryptography. You might be familiar with this with SSH. Oh, I wonder if OpenSSH is more of the that was OpenSSH, not like the SSH. I guess if the server and client agree on it, it's all good. Those more traditionally use RSA and DSA, which is, I could elaborate on public keys here and what the prime problem is. So I want to make a little note here that we want to consider one-way functions. And actually, as things are currently laid out, which is nowhere near enough stuff, we might have room to elaborate on one-way functions. So one-way functions, public private keys rely on one-way functions. So traditional RSA, DSA, or at least RSA that I know of, relies on the difficulty of factoring prime numbers, and I believe it has something to do with exponentiation. It is, if you know the primes, it's very easy to calculate the exponentiation numbers, and you can't go the other way. Something I'll have to refresh myself on before doing this. That discussion of one-way functions leads ourselves into elliptic curves. We start talking about how traditional one-way functions are implemented, we wouldn't necessarily leads us into talking about elliptic curves. So this stuff switches. This could still stay here. Abstract private keys is might be more of a meh. We'll see. So one-way functions are traditionally done via primes, or have frequently been done with prime numbers. There are multiple constructions. One of the ones that is been getting a lot of currency lately with cryptocurrencies, curiously enough, is elliptic curves, which are instead based on, well, certain mathematical structures that look sort of like this. In particular, I think the one SQRL uses is this little curve here. And, you know, this is math and crypto. It's hard stuff. But what I gather from it is that it essentially involves your key is a point on here, and then you like take the tangent to it, and that gives you, and that you know, essentially bounces you to a new point. But you could have arrived at that point from anywhere, so it doesn't really leak information about where you came from. And then you do this multiple times, then it becomes impossible to go backwards through the system. One of the big advantages of elliptic curve keys is that they have elliptic curves, is that they give you very small cryptographic keys. People seem to be settling around 256 bits, which is what you see in Bitcoin and Ethereum, and in the other things that are using this kind of crypto system. You know, the author of SQRL said that 256 bits is the new black. And so they've got small keys. They're still efficient to compute. I know at least the algorithm that SQRL is using also allows arbitrary input, which has some interesting properties I don't know if I'll get into today. And they've been around long enough now that you have lots of good implementations. The one I use is, the one that usually comes up is libsodium. And I have to refresh myself on how that replaced NaCl. I think that NaCl came first and libsodium was a portable version of that. So that is one of our big themes, is that we have public-private keys, and that currently elliptic curves are one of the favorite ways to do that. You know, we've got manageable key sizes, we've got relatively efficient computation, and we've got widely available implementations to use those. This is the part where I do a lot of talking. Another challenge we have is that, you know, like passwords are weak. Even with second factors, you have to consider things like SMS codes being intercepted or SIMs stolen. Well, that's probably not the right place to talk about this. One of the particular problems with passwords is that users just use bad passwords. They tend to use weak passwords. They tend to reuse passwords between sites, even if they get good one. Which tends to lead to all sorts of, you may have heard of Battery Horse, Staple, and company. So we get password schemes, we get user forgetting passwords, we get password reuse. I'll play with how I want to order those. Yeah, but even with a good password, yes, we get schemes to make good. Actually, you want random passwords, but that leads to either you're in danger of forgetting them all, or you end up reusing them. The solution, one of the solutions for this, is a password manager, and if you're not using a password manager, you probably want to. It allows you to use good, unique passwords for every single site. And what a lot of times will happen is, like, if I use LastPass, it will actually be able to very often actually fill in usernames and passwords for you. And it starts to become this thing, an agent, where it is your authentication agent. You don't make up your passwords. You don't, most of the time you don't touch your passwords. You don't know your passwords. The manager is handling it for you. This is something, there are other types of agents. For instance, Google has a scheme where, like, if you say log in, they will, you have an app on your phone, and like they call you, and you answer on your phone that yes, I really want to authenticate to this thing. They'll even sort of use SMS authentication in the same way. The phone is your agent, your phone number. You have to be careful to get your SIM stolen. And agents also become relevant for public keys because that's where you keep the private key side of it. I first encountered this with PuTTY and SSH. They had an agent, since your private key generally wants to be encrypted. The agent will do that decryption for you instead of having to enter your password every single time you use it. It can kind of keep that around in a little bit less protected, transient state. Another form of agent you may have seen is and this is sort of what you see in like a cryptocurrency wallet. The wallet is your private key, essentially, and I'd have to look up if they're storing additional information like, caching current balance and keeping the public key handy. So that is one way that you protect that. Or that's one form of agent, and that's where I started seeing this as a trend that's showing up. We have private keys, we have agents to manage our keys. SQRL is also an agent-based system. It uses public-private keys. The keys are stored in the SQRL agent, and the agent is directly involved in the authentication process, performing various kinds of signatures on your behalf, and can be either local or in a mobile device to have sort of some separation there. Now, in the public key case, one of the things the agent does is it keeps that private key. Now, it's still one of the caveats to public key crypto and agents is that you're dependent on the agent. You must keep that private key, and the user is ultimately responsible for the private key. A website could provide out-of-band authentication if you lose your private key. Call customer support, give them whatever out-of-band information you need to authenticate it's really you, and pray there's no social engineering attack, which is the caveat of that scheme. But it could be done out of band. But if you lose a private key, that's it. That identity could be lost, or the service could provide an out-of-band method to replace it. So that is one of the caveats here. We have a lot of user responsibility, and agents are helping to manage that a little bit. They might have a database you can back up, and we'll get to more into that later. Another thing the agents are doing, and I might actually want to start swapping that and using that as an intro to lots of user information, or even bump that up there. Since the agent is keeping the private key, it's generally very important that the agent is encrypting this information, especially when it's at rest on the disk. So, like even in the password manager case, like LastPass, it encrypts your password database, and when they synchronize it across multiple computers, they are sending an encrypted blob to the service, which is decrypted by the passphrase you use. So that is directly related to the security of that stuff on the net. And one of the things I've been seeing or that I see in SQRL, and I think I would like to see. Well, you also see it to a certain extent in like your phone authentication. I've heard that iPhones, for instance. Well, I mean, even when you first log into, say, my Android account, you have to put in your like Google account password, but thereafter you can set off the unlock to be a pattern or a fingerprint. iPhones do, I understand, do a similar thing, where like when the device starts up, you have to put in your Apple password, and then you can use a pin or a fingerprint to just unlock the device. SQRL uses a similar scheme, and potentially on an iPhone you could even use the fingerprints, where you have a master password that unlocks the vault, and then you will use a shorter password to unlock it every time you authenticate to something, to say, yes, I'm really here, it's still me. But if you flub that short little password, then it says, uh-oh, maybe we're under attack. Now you have to put in your big password. It's not like a 3 times or 10 times you're out, like total account lockout. It's just like, whoops, you failed the easy one, so now you have to do the hard one. Which I think I like, because my main reservation to making my LastPass password harder is that I don't want to type in a 16-character password every time I unlock it, but I also don't want to have it unlocked all the time. So it's just like this trade-off thing. But if we have, so we do have to consider that if we have this total user responsibility, we have to consider loss of user info. So one of the things we see with this is you have totally offline storage backup. Offline storage would be even better. And we saw this, if you're going to put it off MetaMask, you get this set of words, which is, I'd have to see exactly what algorithm they're using. It could either be an encoding of the private key, or it could just be some stuff that they hash down to get the private key. So that is a thing that will recover the key you had directly to from the offline storage. So the user has to take the responsibility to write that down somewhere. If they don't write it down, they don't back it up, we're back to out-of-band recovery. Another trend, in addition to user responsibility leading to sort of requiring user responsibility to back up, is multiple levels of keys. So in both SQRL, and I looked up, it came up in SPIRX Semaphore as something else that does some of this. They also have a backup via words that's your ultimate key, but you don't that's not the key you're normally using. You have that's sort of like that's your emergency recovery code. Most of the time you have this daily use authentication. Actually, what they do is they have a key ring that has all the important stuff, and the recovery code just gives you access to that again and can be used to replace it if necessary. SQRL actually has a backup of the database, which can be in the form of a QR code that can be easily recovered, and then a recovery code that decrypts that information. And on the regular basis, you have the identity master key that's using most of the time. And go this way. So that is your offline backup, and that can be used to recover your identity unlock key, which can create your identity master key. And the multiple level becomes especially more interesting in the case of theft of the user information. So not only do you need to recover it, you actually need to prevent someone else from using that. Now in cryptocurrencies is a little rough, because if they have your account, they have your coins. The only thing there's nothing in the system to do this. What you could do is you could have multiple wallets. You have we talked about the cold wallet last time. Actually, that's what I need to say here. Not it's gone, it's just that we have a cold wallet. That's your second level. And you can transfer into that without any private information. And it sets up the, we talked about the concept last time. So that's trash. So in the cryptocurrencies, like last time, we talked about cold wallets. So this is something you very rarely touch. It's going to be much harder for someone to get a hold of it. You can keep most of your value there, and you can send the currency to it whenever you want to back stuff up. And only when you want to get stuff out do you have to sort of take that out of cold storage. That sort of sets up, it's not built in, but there's like this implicit levels and rights. That the cold wallet has the right to your bulk of your cryptocurrency, and then you've got your sort of daily driver that's, you know, got some small percentage of that available for little purchases. And if you did lose one of your cryptocurrency keys, then you'd lose that little bit of currency, and you'd start using another one, or even use multiple little ones for different purposes. So we also have the concept of rotation of keys. So we've got levels of keys and rotation of the lower level keys as things you can do. Semaphore has your recovery key. There's only one recovery key, but you should rarely use it. From what I can tell, they maintain account identity, but like almost everything you care about is in the key ring. So there's a provision with the recovery key to rotate your key rings. So that replaces the signing key and encryption keys and such, which replacing your signing key is roughly equivalent to what SQRL calls it replacing identity, but the identity is the private key which you use to sign stuff, so it kind of ends up being the same thing. SQRL's main thing is the identity unlock key, which is, I believe it is stored encrypted normally, but it is encrypted by the recovery key, which is offline. I actually need to double check how that's intended to work. But most of the time you use the identity master key. That's the sort of daily driver that you unlock, and which has provisions in the protocol to replace it. There is when you set to a site, you can store additional information that is the lock to lock an account from being further updated. And then when you want to update, you have to provide additional information based on your identity unlock key. And you can provide a previous identity and a current identity and say, well, if you knew me by my previous identity, now this is me, and here's my unlock assertion. Actually, the server can say, I knew you by this previous key, and if you also provide the unlock assertion from your higher level identity, then you can replace that. There is also a provision in SQRL to disable an account with your basic level of key. That leaves room for denial of service attack if somebody gets your account, but the intention is that you go around and lock all your accounts if you lose control. And then you go get your recovery code out of your safe deposit box so that you can go around and replace them, cutting off previous access. Alright, so that could use a little bit more rehearsal. I need to, when it starts to smooth down, I need to start timing it. So I figure out how much more stuff over here I have room to talk about. But that is getting to be about lunchtime for me. So I was hoping to have this in better shape by now in terms of volume. So if this is actually 20 minutes, then I'm going to need to expand it. But I need to start thinking about where I need to expand things and start timing it out. So it looks like we're going to be doing timing runs tomorrow and elaborating things and filling in pieces, which will give me 2 days to actually do slides. Well, 2 to 3 days. Yeah, 3 days. Okay. So that is it for the morning stream. Thanks for hanging out. Where is Switch? Thanks to Arc5, Botsaret Gaming, Sermia Slippered, Cat Knox, Dog and Lake, Begron, and SEO Stuff for hosting me. Let's see, on Twitch, I need to get up to you to see, do we have anything sort of related to host 2? Not quite. Don't know what that is. I think that's got fixed. How about, well, make sure that that's still going. That's the thing I always forget about. Oh. Well, I definitely got a screenshot there. Okay, and then there's that. Alright, so, yeah, so just as X doing Windows. Dead Cells, it's sort of like a road-like, I may have seen the description, Castlevania, Metroidvania thing there. So he's somebody I've enjoyed watching before on some different game. And if you're looking for somebody cool to hang out, someplace cool to hang out, I'll be back to also not included this afternoon to keep checking out ranching stuff. That's that. Thanks for hanging out. Bye-bye. Oh, I don't have... Bye-bye. What am I doing? There's nobody watching. Oh well. Bye.